Every home with fiber internet, every FTTx rollout, every broadband upgrade, someone has to actually build and support that network. Telecom operators and Nokia partners are hunting for engineers who understand fixed access technology from the ground up. That's exactly what the Nokia Fixed Networks Fundamentals certification proves: your foundational knowledge of fiber, DSL, and broadband access networks. In this session, we'll walk through real exam-style practice questions so you can think like the exam and pass with confidence. Let's get started. Question number 1. A QoS policy examines a packet's markings and assigns it to a forwarding class. Which QoS function is being performed? A. Classification. B. Shaping. C. Policing. D. Optical amplification. Correct answers: A. Classification. Explanation. Classification examines packet information and determines how the packet should be treated by the QoS system. The decision can use fields such as VLAN priority, differentiated services code point, protocol information, or interface context. After classification, the packet is assigned to an appropriate forwarding class and queue so that scheduling, congestion management, and other policies can provide the intended treatment. Shaping controls an outgoing rate by buffering excess traffic, while policing enforces a traffic profile by dropping or remarking non-conforming packets. Optical amplification increases optical signal power and is unrelated to packet classification. Effective classification is essential when a fixed access network carries services with different requirements, such as voice, IPTV, management traffic, and best effort internet access. Question number 2. Which Corteca component is intended primarily for use by the subscriber during Wi-Fi installation and management? A. Corteca mobile application. B. OLT network termination card. C. IPFIX collecting process. D. Netconf candidate data store. Correct answer: A. Corteca mobile application. Explanation. The Corteca mobile application provides subscriber-facing capabilities that can support self-installation and home Wi-Fi management. Depending on the enabled service, the subscriber can receive installation guidance, view the home network, manage connected devices, and perform supported troubleshooting or configuration tasks. The service provider uses other Corteca platform components for centralized service management, visibility, and operational control. An OLT network termination card provides access node network connectivity and is not a subscriber application. An IPFIX collector receives traffic flow records, while a Netconf candidate data store holds proposed device configuration before it is committed. Separating subscriber-facing and operator-facing functions allows the provider to offer controlled self-service capabilities without exposing the complete network management environment or low-level access device configuration to the end user. Question number 3. What is a key characteristic of software disaggregation in an access network? A. Network software functions are separated into distinct modules with defined interfaces. B. Every control and forwarding function is permanently embedded in one hardware appliance. C. All network management APIs are removed from the access architecture. D. Passive optical splitters execute the access control software. Correct answer: A. Network software functions are separated into distinct modules with defined interfaces. Explanation: software disaggregation separates access network software into modules, with each module responsible for a particular functional area. Defined interfaces allow these modules to interact with one another, with higher-level applications, and with abstracted hardware resources. This architecture can improve development flexibility, automation, scalability, and the ability to introduce new functions without replacing an entire vertically integrated platform. It does not mean that all physical constraints disappear or that every module can operate on every device without adaptation. Embedding every function permanently in one appliance describes a tightly integrated architecture rather than disaggregation. APIs are important because they enable communication and programmability between components. Passive optical splitters cannot execute software because they contain no powered processing or control functions. Question number 4. Which altiplano intent is used to define the uplink interfaces that connect an OLT toward the aggregation network? A. Uplink connection intent. B. Subscriber authentication intent. C. Wi-Fi radio intent. D. Multicast report intent. Correct answer. A. Uplink connection intent. Explanation. The uplink connection intent defines how an OLT connects toward the aggregation or transport network. It is used to configure relevant uplink resources, which can include network-facing interfaces and associated parameters supported by the device and intent model. This intent is distinct from the broader device intent and device configuration information used to identify and configure the particular access node and its assigned profiles. Subscriber authentication, Wi-Fi radio operation, and multicast membership reporting are separate functional areas and are not substitutes for the OLT uplink connection intent. By representing uplink connectivity as an intent, Altiplano can translate the desired connection into lower-level device configuration and apply it consistently through model-driven management. The resulting configuration must still match the capabilities and physical resources available on the selected OLT. Question number 5. In intent-based networking, what does an operator primarily specify through an intent? A. The desired network outcome or state. B. Every electrical characteristic of each hardware component. C. The optical power measured at every point in the fiber. D. A list of packets that must be forwarded individually. Correct answer. A. The desired network outcome or state explanation. An intent describes the desired network outcome or target state rather than requiring the operator to manually enter every device-level command. The intent system maps the requested outcome to the configurations and resources needed on the relevant network elements. It can then compare the intended state with the observed operational state and take corrective action when supported. Intent types, profiles, and associated models provide the logic and parameters required for this translation. An intent does not normally specify the electrical construction of hardware or list every packet to be forwarded. Optical measurements may be used as operational inputs, but they are not the general definition of an intent. This abstraction improves consistency, supports automation, and reduces repetitive device-by-device configuration work. Fixed and fiber access networks are the backbone of modern broadband, and skilled engineers are always in demand. Passing the Nokia Fixed Networks Fundamentals exam proves you can. Understand fixed access technologies like PON, DSL, and FTTx work confidently with CPEs and broadband architecture. Apply core networking principles to real access networks. Build a foundation for advanced Nokia Fixed Networks certifications. Don't rely on guesswork on exam day. Use CertBoosters practice questions to sharpen your fixed networks fundamentals. Reinforce key concepts and pass the exam on your first attempt. Start practicing now via the link given in the description below, and take your first step into the world of fiber and broadband networking.